the challenge for us as futurists and innovators and leaders is to work with you in creating a collaborative human AI-enabled future. Now that's my point of view. My panelists may have other perspectives about that. The other is to be able to consider, and here's a challenge for all of you, since the Institute for Global Futures advises governments as well. How will you collapse time? How will you deliver better quality services, value, predictions, forecasts as government leaders? What will you do to be able to leverage AI in a collaborative way so that each person that's working can understand how to be able to maximize AI as a tool set to be able to create exponential change? How do you collapse time? Not work on it 10 years, 3 years. How about 30 minutes? How about 3 minutes? So as an AI innovator in my own business and consulting with companies, the challenge is how do you do more of what you want to do faster, better, and deliver and empower more opportunities than ever before? That's your challenge, not ours. Not magic bullet AI. It's really an enabler to be able to transform government for the future, meaning 1 minute from today. And with that, I'd like to introduce our panelists and start. I'm going to give Jan a few moments to relax here, and maybe we'll start at the end with Serge. And I believe you've been introduced, so the floor is yours, sir.
So I am a physicist working in quantum science. I did not use AI during my career because AI did not exist or was not developed enough to do the kind of things I'm doing. But I see now AI as a fantastic tool to improve ways to accumulate data, to compare data, to make correlations. I see AI a little bit like powerful computing was 50 years ago. When I started my career in research, computers were very, very poor in calculation. In fact, the cell phone that we have today is more powerful than the big computers that we had in the 70s. And so the computer made a big revolution to control experiments, to accumulate, to make calculations of difficult situations. And now AI is bringing us a step further. I see different domains in physics in which AI is already very useful. When you have to accumulate a lot of data, for example, in particle physics, looking at the data that accelerators give you, or in astronomy, when you have to compare pictures of some part of the universe, which we can take either with visible light or in infrared or microwaves, or now even with gravitational waves, if you compare this huge amount of data and make correlation, you can increase the resolution that you get from just one set of data, and this is very useful. In my field, which is quantum science, what we try to do is to prepare atomic system in states which are called superposition states in which the system is at the same time in different states at once. It's what is called, in popular language, a Schrödinger cat state, a system which can be either dead or alive at the same time, and these states are very fragile. If you have to keep this state alive, which is required if you want to do, for example, quantum computing, you have to be able to protect these states, and AI gives a way to do that. AI gives a way, it's called reinforcement learning. You study the system, and from what happens to it, you find ways to correct and to keep this superposition alive. This is a very interesting way to make what we call quantum error correction codes, which would be useful if one day we could build a quantum computer. So it's still very tentative, but it gives you an idea of what AI can do. You can, in a way, compare it to the way you use AI to make automatic drive of cars. You have to look at the environment, and then the system decides what to do. Here we have to look at the environment of the quantum system and find ways to correct the errors which may happen. So it's very difficult, and it involves a huge number of parameters that you have to control, and this is a domain in which AI can be useful. So that gives you an idea. I don't think AI will solve problem replacing human mind, but it's a tool. And in the end, if you want to understand the world deeper, I think you will always need human minds. This is my optimistic view of the future, so I would like to know what you think about that.
Thank you. Thank you. Please.
Thank you very much for the invite to the panel, and delighted to be here. Why have you got someone from tech sitting on a scientific panel? Well, actually, I think it's about partnership. And where we're going in, particularly developing our AR tools, deployments across the cloud of large language models, and what we can do to enable scientists to move forward in their pursuits and discoveries, is that key partnership. And the role I do in Microsoft, it's also those discussions with government around the policies of how do we use AI, how are you thinking about the privacy, how are you thinking about where your data was. I heard the end of the last conversation around sovereignty, etc. But how are we using AI to make things better for the citizen and also the workforce within the government, and as we go forward with research? Because taking that research and then turning it into something that people can use to make the world better is where this partnership comes together. But when we look at AI from the Microsoft perspective, what I'm looking at from us, and Satya, our CEO, has said it already, is when we look to the future, particularly in chemistry or material science, how are you going to compress the next 250 years into 25? So picking up on the moderator's comments already, how are things going to go faster? You know, ChatGPT made 100 million users in 2 months. A mobile phone, it took 18 months to get that. So what we're seeing is pace of change and expectation and drive to make things happen a lot quicker. And therefore, how we get to grips with this fast-moving, agile technology, and how do we expand ourselves, the compute power that's required, to eventually go even to the quantum space and our high-performance compute. Everybody talks about AI. For us, it's also the underpinning infrastructure to make sure that the scientists get what they need to test in the models they do that. But it has to have trust. And where responsible AI is key from some of the stuff we're doing. What are the principles? But how do you hold those principles? How do you hold people accountable for them? How do you measure them? How do you audit them? Is again a lot of the discussions we're doing with governments around the world on how we can do that, not just in the scientific sector, but also across how government and public sector does its business with AI going forward. And then the same thing goes on skilling. And this is not technical skilling. This is how do you manage things like GPT? How do you manage those neural language models that you need to take forward when you're in your discussions? And that's showing a different skill set. It's like they're the co-pilot. AI is the co-pilot, and it's driving that technology and understanding how to communicate with it, how to rationalize it, how to understand is the analysis you're giving going forward. So we're seeing AI fundamentally changing the way of business in the workplace, organizations, and acceleration for the scientific community.
Thanks. Jan?
Yeah, I want to expand on something that Serge just said. One application of AI or promises of AI that sometimes is eclipsed by writing aids and generative AI and things like this is in the sciences. So AI accelerates the progress of science. In some cases, can discover or build models of phenomena, physical phenomena, that for which we don't have sort of first principle theory, because those phenomena reflect collective properties of complex materials, for example, for which we don't have kind of first principle ways of really figuring out the properties. And we might be able to do detailed calculation to predict those properties, but it's too expensive. So let me take an example. Let's say we want to solve climate change. What is the biggest problem in climate change? The biggest problem is energy storage. If we had a very efficient, large-scale way of storing energy and shipping it wherever it's needed, we would easily cover a small part of the UAE desert with solar panels, and that would be enough energy to power basically this hemisphere. But to be able to do this, you need to be able to store the energy that is produced when the sun shines, unlike yesterday, and then ship it wherever it's needed. To do this, the best way to store energy is in the form of hydrogen or maybe methane. So you need to break up water molecules into hydrogen and oxygen. And we all done this experiment in high school where you put two electrodes and the oxygen goes one side and hydrogen the other side. Unfortunately, that's not efficient. The way to do it, make it efficient is you have a catalyst, and the best catalyst we know is platinum. Platinum is too expensive, so it's not scalable. So the big question, if we had an answer to it, would be, is there a catalyst that can facilitate the separation of hydrogen from oxygen that does not require any exotic material and can be scaled enormously? And we would solve climate change. Now, that's pretty tall order, and some of my colleagues actually started a project that use detailed computation, quantum computation, DFT actually, density functional theory, and you can, with a supercomputer, compute the properties of a particular material, tell whether a molecule of water is going to stick to this material in a particular way, and then predict perhaps whether it's going to facilitate the reaction. Now the problem with this is you need to explore a number of possible material, which is enormous, and you can't do that simulation with the required number of times. So what you do is you train a deep learning system to predict the properties of that material using training data generated from the calculations. And perhaps with this, you might be able to discover new materials. And it's not just for climate change and saving the planet. It's also for new LEDs, high-power LEDs, new materials for displays in augmented reality glasses, or all kinds of things that might appear because of this. I've heard the statistics. I don't know if you heard the same one, but 12% of all the physics papers published today mention deep learning or AI. That tells you something, right? But for now, it's still a promise, right? There's no one has received a Nobel Prize by making a discovery that used AI yet. You got one without actually requiring AI, but that might happen in the future. And same for applications to biology and things like this. So we're talking about safety. This panel after all is about safety. If you want to talk about safety, you always have to do a risk-benefit analysis, and when we talk about safety, we don't talk about the benefits enough. So I think we've just talked about some of the benefits in some corner applications. Now, what about the risks? So a lot of people, because they're not involved in AI research, see the progress of AI as some sort of natural phenomenon that just occurs that they can do nothing about. But it's not the case. It's done by people like me, like some people in the room. So we have agency in the way AI is being developed and deployed. And there is no way to deploy it in a safe way, any particular subset of technology, we're just not going to deploy it. There's a lot of technologies that were invented and never deployed, like nuclear-powered cars. We can't buy nuclear-powered cars because it's not safe. So I think it's going to be the same for AI. And AI safety is just better AI. There's this idea somehow that you should have separate organization working on AI safety. It's just not true. Safer AI is better AI. The same way that safer turbojets are just better turbojets. There's no separate turbojet safety engineers. I mean, there are, but they work together with the designers. So I don't think there is anything special about AI in terms of safety compared to other technologies.
Excellent comments. I'll just add to that, from a government policy point of view, I've been involved with a number of initiatives, and what you want to take away from this is to be able to create, I believe, policies that will be good for creating jobs in your societies, leveraging the innovations that we're talking about. This one just happens to be AI. The ones that I worked on had to do 15 years ago in the US with the National Nanotechnology Initiative, manipulation of matter at the atomic level. I believe you all know something about that. We asked the government for the US $1.3 billion under the Clinton administration for an industry that didn't exist, for a technology that was just emerging, it wasn't mature. and we sold it by promising jobs, new economic infrastructure, and that has pretty much occurred. So if you're out there looking, well, how are we going to get support for AI? Well, if you tie it to a grand vision, or in the US we call it grand challenges or world grand challenges, what are the grand world challenges? Poverty, hunger, security, better job creation, human health enhancement. So you mentioned climate change. Well, quite frankly, we're beginning to see, because one of the key elements of dealing with grand challenges has to do with data. Not just data that you have or data you don't have. How will we decarbonize the planet? How will we be better forecasting the impossible, which is climate change risk impact on infrastructure and real estate and health? How will we fix and figure out cancer and other kinds of complex illnesses that we have data on, but we haven't figured out how to be able to correlate it? Could AI help? We don't have answers for that, but we believe that this tool, and what you're hearing in the earliest stages, could be a super tool for the transformation of grand challenges, whether you're in Dubai or in the Gulf, or you're dealing at the global level. So that's the challenge for all of you to take away. It's been done before. Singapore, I work with, and we did something very similar to support the innovation economy. They put the internet in the entire island, the first nation to do so. What did that do? It created very fast way for connectivity, for data, for tool sharing and collaboration. So my takeaway for you is human and AI collaboration could collapse time wherever you are. And this is not an issue of really money per se, or the West has invented this and the rest of the world. No. This is a level playing field, an opportunity. Think about, I make policy around Moore's Law. Remember Moore's Law, the co-founder of Intel. Every technology, every microchip, and now every technology doubles in power, not just every year, but every 3 to 6 months. That same period of time, the cost basis for that power decreases by 50%. Now think about that for every innovation. Apply it now to AI. There are some things about where we're going to get the data for that Jan has mentioned before, but this is a big opportunity to collapse time and be a more efficient, I believe, government innovator in supporting science, breakthrough. Someone told me recently about the need for more, not just applied science, but basic science. So I'm going to take that wisdom from Professor who informed me about that. So that's my take. This is your challenge, not just us telling you, hey, this is what's happening. This is your opportunity. These tools are for you. Now, I'd like to ask the rest of my panelists, I'd like to pose a challenge, unless Serge looks like you have something to share. No? Okay, here's a challenge. How can all of these government leaders, enablers, how can they be more effective in supporting science with AI? Is it about money? Is it about people? Is it about the right policy? What would you suggest could accelerate opportunity so they can enjoy the benefits of this new tool set of AI? Please, whomever.
I think they have to favor education at the start, because first of all, if you want to use AI, you have to understand exactly what kind of tool it is and in which direction can help, and for that you need educated people. You need also educated people because AI has also a negative side. It's a way which allows you in communication to manipulate people, and we have to understand that for people to be able to use it in the right way. And you need also education because you need to train boys and girls alike, and you need more girls into the information sciences, including AI and this kind of thing. So I think this is a very important issue, not only here, but anywhere in the world, and I'm always advocating for that. I think we have to discuss also what AI does in the realm of communication. We talked about the fact that it's a fantastic tool to analyze data and to predict new forms of matter. For example, you take the example of a catalyst for hydrogen. Another example which might help climate change, if you can discover a high TC superconductor, which will allow you to carry electricity without losses. And again, to find the right material to do that, you have to try a lot of structures. And again, AI can be very useful to do this training. So this is a very important point. What I wanted also to tell that in the domain of research, you have, first of all, you have to do the research, and then you have to communicate it. And for that, you have to write papers. And AI is a fantastic tool to write a paper. I know that, for example, if you have done an experiment, and if you ask ChatGPT to write the introduction of the paper, usually he will do it better than what you would have done yourself. So it's a very useful, powerful tool, but you have to be careful. And I think it would be very important in the future that when you have used the help of AI or ChatGPT to do something, that you have to mention it. I think it's important. It's an ethical issue. You have to make clear that you have been using AI for what you are doing. This is true also for translation. I think there is a big problem now facing translators. When you write a book and you want to get it in another language, you can use automatic translation, but at some point you need the help of a human being to make sure that the translation is okay. Maybe it will not be longer necessary in the future, but for the time being, I think it's a very important issue, ethical issue, to know exactly if the work has been done by a machine or by a human being.
Very good.
When I've been having this conversation with governments, it invariably comes around to some of the policies and how they think about their research and development. And also how they think about, when they're proving stuff, the route to market. And that invariably comes into what value they're getting and where they're thinking about taking it to the market to solve complex problems, be it in health or defense or justice, or even in the smart cities that are growing that we see all around the place. And that then drives to a financial discussion, because the investments into the research and development sector then sometimes don't translate across into the actual day-to-day departments of state. And that's where, when we need to align where research is going, giving them the appropriate funding to then make sure that when they've delivered the results they need, we can then commercialize it and take it to industry. And for that, this conversation is how we take research. How do you encourage startups? How do you encourage new research, as opposed to we have to have trusted procurement practices that take larger, mainly the bigger organizations? So how do you get that startup mentality? So for me, with AI for governments and driving forward in research, what AI has done is changed how you think about risk. And how do you manage risk? You do not need to be totally risk averse to certain capabilities, depending on whether it's risk to life. So what are you trying to do and what level does it, instead of applying the same risk view to everybody? And that really comes back to some of the conversation at the beginning of trusting AI, seeing the benefits of it, as well as being wary of how you do it responsibly, because there are disadvantages that you need to be conscious of. And that, to me, if we can get over that hurdle, we will move a lot faster in how we can deliver AI. Because at the moment, there's a lot of governments, a lot of cross-government agencies talking about AI safety, etc., without thinking, how do I increase productivity? Because that's the time issue. It's not about time and compressing time. How do I get better productivity for the nation, the citizens that I'm supporting, and the workforce?
Please.
I think I'll echo what Serge was saying about education. Certainly education is a very important component, and the UAE in the domain of AI certainly has done a lot to attract talents with MVZ UAI that was created fairly recently, the only university in the world entirely devoted to AI, and with the NYU Abu Dhabi campus. I'm professor at NYU, so I'm sort of preaching I'm a little biased there. I'm actually going there in a few days. But I think this is really, really important. But beyond education, and this is certainly addressing the issue of gender balance that also Serge was talking about. Before you get people to study science, computer science for AI, or engineering, or physics. Actually, it turns out physics training for AI is great. It's the same mathematics behind it. You have to inspire young people to want to do it. You know, it's difficult. So young people have to somehow be attracted by the idea of doing studies in those domains, and then being interested in innovation, perhaps in research, embarking on doing a PhD, for example, to get in research. A lot of companies in AI are founded by people who have gone through a PhD, maybe worked for a few years as scientists in big labs, and then started their own company. So how do you motivate young people? How do you inspire them to do this? I think that's a more important question. And I'm going to mention one example. There was basically no AI ecosystem in France 10 years ago. There were people in academia working on AI, of course, very high level, a lot of engineering schools, very high quality, a lot of talents, but very few perspectives of opportunities for career in AI or in industry research if you are interested in those domains. And that changed. And it's changing even faster now. And it changed because now there are opportunities for young people to actually do a career. You know, people coming out of the top schools and universities, 15 years ago, they would go into finance. Today, they go into AI. It's the cool thing to do. And unless a technology is seen as the cool thing to do for young people, they're just not going to study for it. I think some of the issues that we see with gender balance in many countries, in engineering, science, and physical sciences, for example. You know, in computer science, the proportion of women across the world is about 20%, majoring in computer science. In electrical engineering, it's closer to 15%. In physics, it's like 10%. It's not because those domains are more sexist or anything like that. You know, why did we get to parity in other domains like law and medicine and everything? It's because of cultural, you know, pressure for young girls to not study science, which, you know, is mind-boggling because we're kind of wasting half of our population. So inspiring the youth to actually go into those domains and giving them opportunities for career will incite them to actually study and create an ecosystem.
So I know we're close to running out of time, so I'm going to make a couple of final remarks. Thank you, first of all, panelists. Let me create a challenge for all of you, okay? This is not just a panel about some interesting professors and stuff we're doing. This is an invitation for you to join with us in creating the future. Anybody interested in creating the future? Show of hands. Anybody? Anybody? Yeah. Imagine being able to map cancer, let's say throat cancer. There are 18,000 articles a month that are published. No human can read them. But an AI could read them. And what could an AI do? Could determine what are untreatable cancers that could be treated with other kinds of interdisciplinary approaches that you'd never, if we took everybody in this room, we added by 1,000, you wouldn't maybe be able to read all those papers and do all that correlative research. You're dealing with lots of data in every area, whether it's security or basic sciences or research in biotechnology, or you need help. Imagine no longer that you have one researcher or person you're talking to. Imagine you've got 1,000, 5,000, and their specialty is to read all these papers, analyze them based on this, and then feed them into basic research, direct research, and then collaborate with UAE, Qatar, Marseille, US, you give it. That's the global opportunity. If we're going to decarb the planet or understand how climate change is going to create risk, what does that mean? It may mean that you need help. So this is a synthetic intelligence revolution. This is not just another interesting tool. It's a collaborative synthetic intelligence and human intelligence opportunity to transform the planet and pick some of those big millennium goals that we all talk about. This is a way to accelerate time if you want to take it. I'd like to thank my panelists for participating. I'm sorry this is so short. We could go on, but I believe I have to stick to the schedule. Thank you for your highnesses for inviting us, and I wish you all well and see you again in the future.